POE students, another tutorial here. This one is going to talk about variables. Variables are pretty simple. They're essentially just a way for you to keep track of something in your program. Uh, it's just another way for you to exert more control over what is going to happen on the output side of a device or whatever you're making. So I'm going to give you a couple examples here in this video, and hopefully you'll get the idea of it. So the first one I'm going to talk about is actually you see in your PowerPoint, and it's called, if you look at the PowerPoint, it's keeping track of how many times a bump switch is pressed. So essentially what we want to do is first look at two different kinds of variables. At the bottom there are local variables and global variables. The main difference between global and local variables is where they can be manipulated and where they are in a program. A global variable is usually defined outside of task main, and it can be manipulated by anything inside of task main. Local variables, they exist inside of task main. More specifically, they can exist inside of functions, and if there is a function, which we'll talk about in a little bit, it can only be manipulated by that function that it is in. For the most part, you want to use local variables so we don't get programming that's screwy. But in this case, what I'm going to do is actually assign all my variables to become global variables. Ignore the speed one right here. We'll get to that in a second. But yeah, so we're going to go with all global. And the reason that we're going to go global here is to actually give you a visual representation of what's happening with the variable. In RobotC, they do not display local variables, but they do display global variables. So that's what we're going to use. So first, after you look at the PowerPoint, essentially we're just going to keep track of the number of times a button is pressed. So first we have to create a variable which is going to contain that data. The data we're going to contain is just going to be a number, 0, 1, 2, 3, 4, 5. So to create that variable, we're going to go int. What that's going to mean is that we're going to create a variable that's going to be an integer. Essentially, any positive whole number, or I should say any positive or negative whole number, including 0, can be in this integer. There are other ways to create other variables. We can create character variables that just deal with like the letter Y or L. We can do strings, which are like full sentences, say like hello world. But they're not very useful for RobotC. So we're just gonna look at integers right now. So we're gonna go integers, and we're gonna create one called number of presses. And right away we're gonna set that equal to 0. So if we look at our program, take a look at how I set up variables. This is generally a pretty common programming vernacular. When you create a variable, the first letter of the first word is lowercase, and then all the preceding first letters of the next words are uppercase. I call this like a drinking camel. You know, the first one's lowercase, the head is down, and the other two are capitalized. Those are the humps of the camel. So kind of weird, but it is something that happens. It's out there. So we're going to create integer number of presses, and we're going to set that equal to 0 right away. So now what we do is in our task main, we're going to create a while loop, and we're going to set this equal to our value sensor, and we're going to say that our limit switch equals 0. I'm going to put a open curly brace. And so what that's going to do is while the limit switch is not pressed, it is just going to look at, it's going to continue to run whatever our while loop is. So next what we're going to do is we are going to look at if our bump switch is pressed. So if our sensor value of our bump switch equals 1, what we're going to do is we are going to take number of presses, and we're going to set that equal to number of presses plus 1. So if the bump switch is equal to 1, we're going to go number of presses equal number of presses plus 1. And then because bump switches and limit switches, they act very weird mechanically. As you press a button or you release a button, it essentially is measuring if voltage is going across, I guess, like an anode and a cathode. There are essentially two pieces of metal inside the switches. And when you press it, it completes a circuit. Well, as those are opening, as those buttons are opening or closing, voltage can jump between those air gaps. So what we have to do is we don't want this to just go exponentially up. So once the bump switch is down, we're going to tell it to add 1, and then we're going to wait for our program until the release of that bump switch, and then we're going to add in a very small wait. And what this will do is it will wait for that bump switch to be completely disengaged or open before it starts reading our values again. Because if it does, then the voltage can jump back and forth inside the button and it can create a ton of numbers. So I'm going to put an end curly brace for my if, and I need one for my while. So we're just going to go ahead and compile this program. We're going to make sure everything's set up, everything compiled nicely. So let's go ahead and download this and let's see what happens. Okay, so I got my global number of presses equals 127. I'm going to hit start. You can see it's set to 0 because my program first tells it to set to 0. And then the while loop is running because the limit switch equals 0. So now I'm just going to go ahead and use my finger. I'm going to press down the bump switch. You can see 1, 2, 3, 4, 5. And I can continue hitting that bump switch as many times as I want. I can go all the way up to 40 if I want. So right there, that can keep track of what's going on. So for example, you all have TVs, you have remotes, you hit that volume up and it goes to 39 and it goes to 40. So that essentially right there, ladies and gentlemen, is a variable that's keeping track of the volume. So when you go to hit down, it takes and apart what that is, and will actually subtract from your volume to bring it down to 39, 38, or going up. So that's just a little bit more involved programming, but it's the same way. You guys see it on your TV. Oh, it's sitting at 30, now 31, 32. That's just variables programmed from the manufacturer of that TV. So that's a very simple way for a variable. I also want to give you another one real quick. So let's go ahead and set this while loop. I don't know what I want my condition to be yet, so I'm going to wait. So this time I'm going to set a new variable, and I'm going to call it speed. And I'm going to set it equal to 63. Actually, you know what? I will set it equal to 20. So very low speed. And what I'm going to do is I'm going to start a motor, and I'm going to turn on the right motor. And this time, I'm going to tell it to read the variable of speed. So it's going to start the motor. I'm going to tell it to wait half a second, and then I want it to take that variable and set itself equal to itself plus 2. How about? So essentially what it's going to do is it's going to start the motor. It's going to start the right motor at a speed of 20. It's going to wait half a second. Then it's going to go speed equals speed plus 2. And it's going to set that again in the while loop as long as something's true here. So now I'm going to do this. I say want my motor to turn off or the while loop to stop once my speed gets greater than 127, or essentially 126. So it's going to say while the speed is less than 127, continue to run this. So let's go compile program. Okay, so I got some errors. I've got some while loop errors. So I just had to put another curly brace. It's very easy. You just read down the compiler errors here at the bottom. So I'm going to go ahead and run that. And I'm going to go to my global variables right now. I'm going to hit start. It's going to set the motor to 20. And you can see here it's starting to increment up. And you can actually hear the motor getting faster and faster. So now we're here approaching 100. What should happen is once it gets to 127, the program should terminate and be done. So you can see there it got to 128, which is less than 127, or I'm sorry, which is greater than 127. So the while condition was no longer true, so it stopped. So you can see there that another way to use a variable, and that's just to ramp up speed of a motor. How useful is it? I don't know, but that could be one thing that you could do. A lot of people like to use servo motors for bins on their material sorter. So as your material sorter is working, you might have a servo bring a new bin around and drop a marble into it. Well, servos run very fast, so a variable would actually be a very, very easy way to control the speed, and I'm putting air quotes, speed of a servo, because you can't really control the speed, but you could have the servo tick up to a certain servo position very slowly, so your servo is not just sloshing around and throwing marbles out of its bins, which is something that very common happens. So there's a little video on variables, and go ahead and watch functions next.